We have two things that we're going to be working on with this video. The first one is how do we find the area of a regular pentagon? Now, hopefully, two things in play with this one. The first one is, what is a pentagon? Now, ladies and gentlemen, hopefully you remember this, but penta means 5. Pentagon means a 5-sided figure. The second part is the important part, is, well, not that pentagon's not important, but regular is the important aspect. And when we talk about regular, we talk about a shape in which all the sides are the same. So a square is a regular rectangle. A equilateral triangle is a regular triangle in which all of the sides are the same length. So what we want to try and do, to the best of our ability, because we're not at all perfect, well, most of us aren't perfect, we're going to draw a pentagon here, and we want that all the sides are the same. Now, as you can tell, I'm not even close because, well, I'm just free drawing. So what we do to help show is that if I do give this one a line, 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 that's what mathematicians do to signify that all of them are the same length. Now what we want to do is we want to find the area. We want to find the area of the triangle, and then we want to find, using that information, find the area of the pentagon. Now, this is something that's only going to work with regular pentagons. First thing we're going to do is we need to make a triangle. And to make a triangle, we're just going to find the midpoint, and we're going to make 2 lines like that. Alright. Now, in doing this, first thing we're going to do is say that this line right here, okay, this line segment is 3 centimeters. And if I were to draw my height right here, that is 4 centimeters. So the question becomes, what is the area of, let's switch colors here because we can, what is the area of this triangle right here? Well, the formula for area of a triangle, as everyone remembers, hopefully you remember, is 1/2 base times height. We know our base is 3. Our height is 4, and then we're going to multiply those two together and divide by 2. 3 times 4 is 12. 12 divided by 2 is going to be 6 square centimeters. Now, we're going to use that knowledge to determine the area of the pentagon. Now, if you notice, this is one part of the pentagon. How many other parts are like this in the pentagon? Well, this is 2, 3, 4, 5. We have 1, 2, 3, 4, 5. We have 5 triangles. So we're going to take our area of the triangle, 6, and we're going to multiply it by 5, and we're going to get 30 square centimeters. Now, again, ladies and gentlemen, it is very important to remember that this only works in a regular pentagon if all of our sides are the same. That's why we denote them with these little hashes. We can also do the same with a hexagon. And again, what we're going to do is to denote that they're all the same, we're just going to put a hash mark there. And that just tells us that those sides are all the same, even though they don't look like it. And the higher you get in mathematics, the more you'll see some stuff like that, especially when we're talking with geometry. Again, we're going to make our triangle. And we are going to be looking for the area of the triangle. And then we're going to look for the area of the, and in this case, hexagon. Oops, I probably should spell hexagon right. I think it's like that, hexagon. And again, this is a regular hexagon. So we're going to need some measurements, and in this case, our base is 4 centimeters, and let's go be consistent with what colors we use. Then we use 4 centimeters here. And our height, ladies and gentlemen, let's just call that, let's call that 4 centimeters as well. Now, using this knowledge here, can we find the area of this triangle? Well, to find the area of the triangle, we're going to take 1/2 base times height. So we're going to take 4 times 4 and we're going to divide it by 2. 4 times 4 is 16 divided by 2. We're going to get 8 square centimeters. Now, how many triangles are in a hexagon? Well, to do that, ladies and gentlemen, we have to go from the same midpoint and go to each one of the vertices. Now we count how many triangles we have. I feel like they count 1 triangle, 2, 3, 4, 5, 6. So 6 triangles total. We're going to take the area of this triangle here, which was 8, and we're going to multiply it by 1, 2, 3, 4, 5, 6. And we should get, oops, I'm looking for the right color here. We should get 8 times 6 is 48 square centimeters. Now, ladies and gentlemen, after that, hopefully please check with Mr. Winkleman or your table mates if you don't understand it. But what I would like you to do, I would like you to revisit our question for today, is how do we use our knowledge of finding area and perimeter to find the area and perimeter of complex figures? When you have a good answer with that, check with your table mates, see what they have to say, and then go talk to Mr. Winkleman, because I'm pretty sure if you have a good answer, he has a gift for you. All right, talk to you in a bit.